North Africa, 1942. Every morning, long before the first tank fired a shell, another battle had already begun. It wasn't fought with artillery, or machine guns, or fighter aircraft. It was fought with fuel. On paper, the Allied armies possessed overwhelming industrial power. American factories could produce more gasoline than Germany ever dreamed of refining. Tankers crossed the Atlantic carrying millions of gallons every month. Convoys stretched from Britain to Egypt, delivering enough fuel to keep entire armored divisions moving across the desert. Yet something impossible kept happening. For every 100 gallons loaded onto Allied trucks, as much as 30 gallons never reached the front. It simply disappeared. Not because German bombers destroyed it. Not because enemy commandos stole it. It leaked away. Day after day. Convoy after convoy. Thousands upon thousands of gallons vanished before a single engine ever started. Meanwhile, German armored columns, operating with far fewer resources, somehow managed to transport their fuel across the same brutal terrain with surprisingly little waste. British logistics officers couldn't understand it. American engineers couldn't explain it. The fuel was identical. The trucks were similar. The roads were equally terrible. So why was one army constantly running out of gasoline, while the other seemed able to squeeze every possible mile from every shipment? The answer wasn't inside a refinery. It wasn't inside a tank. It wasn't even inside the fuel itself. It was hidden inside a humble steel container that looked so ordinary almost nobody questioned it. A 5-gallon fuel can. One design would quietly become one of the greatest engineering achievements of the Second World War. The other would become one of the Allies' most expensive mistakes. When most people think about military inventions, they imagine famous weapons. The M4 Sherman, the Supermarine Spitfire, the Boeing B-17 Flying Fortress. Rarely does anyone think about fuel containers. Yet every tank, truck, airplane, and motorcycle depended entirely upon one simple fact. Fuel had to arrive first. Without gasoline, the most powerful army in the world became little more than expensive scrap metal. Military planners understood this perfectly. An army didn't advance because it owned tanks. It advanced because someone, somewhere, solved the impossible problem of keeping those tanks supplied. Before the war, transporting gasoline remained surprisingly primitive. Most nations relied on thin rectangular tins or bulky cylindrical cans that had changed very little since the First World War. They worked. Mostly. Until conditions became difficult. Long truck journeys over rough roads caused seams to crack. Handles broke. Caps leaked. Workers often needed funnels to pour fuel without spilling it everywhere. Even worse, most cans required 2 soldiers simply to carry them efficiently. Every transfer wasted time. Every damaged container wasted precious gasoline. During peacetime, these inconveniences seemed acceptable. War changed everything. Germany realized that future wars would depend on speed. Not simply faster tanks. Faster logistics. If armored divisions outran their fuel supply, victories would disappear overnight. Long before the invasion of Poland, German engineers quietly began redesigning something almost nobody considered glamorous: the fuel can. Their instructions sounded deceptively simple. Make it stronger. Make it easier to carry. Make it easier to stack. Make it almost impossible to leak. Most importantly, design it for exhausted soldiers operating under fire. What emerged looked surprisingly ordinary. A rectangular steel container holding roughly 20 liters. Nothing about its appearance suggested revolutionary engineering. its genius remained almost completely invisible. The first feature people noticed was the handle. Actually, handles, 3 of them. Most fuel cans used a single center handle. German designers chose 3. At first glance, it looked unnecessary, even wasteful, until soldiers actually used it. One man could comfortably carry a single full can using the middle handle. 2 men could rapidly pass multiple cans down a supply line without changing grip. Empty cans could be carried 2 at a time. Loading trucks became dramatically faster. Small improvement. Huge consequences. The body itself also looked unusual. Instead of relying on flat steel panels, the sides featured large X-shaped indentations. Many observers assumed they were decorative. They weren't. Those pressed shapes dramatically increased structural strength without adding significant weight. When trucks bounced across terrible roads, the can flexed instead of splitting. When stacked inside transport vehicles, the walls resisted crushing. When dropped, the impact spread across reinforced surfaces instead of concentrated weak seams. Engineers had quietly solved problems soldiers experienced every single day. Then came the welds. Rather than joining metal with long exposed seams prone to cracking, German manufacturers developed a method that significantly strengthened the entire structure while reducing leakage. Again, not exciting, not glamorous. But every improvement meant fewer lost gallons. Few civilians ever appreciate logistics because success looks boring. Failure looks catastrophic. There was another clever detail. Air, or more specifically, getting rid of it. Traditional fuel cans often glugged while pouring. Liquid surged, stopped, surged again. Fuel splashed everywhere. The German design incorporated an internal air channel, allowing gasoline to flow smoothly and continuously. No funnel. Far less spilling. Faster refueling. Imagine dozens of trucks waiting in darkness while aircraft circled overhead looking for targets. Saving even 30 seconds per vehicle suddenly mattered. Finally, the lid. Simple, strong, brilliant. Instead of requiring threaded caps that clogged with dirt or became impossible to remove while wearing gloves, the German can used a cam lock mechanism. Open. Pour. Close. Done. No tools. No wrench. No damaged threads. The rubber gasket produced a remarkably tight seal. Dust stayed out. Fuel stayed in. Water stayed out. Every tiny detail reflected one central philosophy. Designed for war, not for the factory. German soldiers quickly gave the container an informal nickname. Soon, it appeared everywhere. On trucks, half-tracks, motorcycles, armored cars, even strapped to tanks heading toward the vast open spaces of North Africa and the Soviet Union. At first, the Allies barely noticed. It was just another enemy fuel can, one more piece of equipment among thousands. Nobody imagined this simple steel container would soon become one of the most copied military designs in history. But first, the British would have to discover, the hard way, exactly why Germany had built it differently. And by the time America decided to copy it, one tiny missing detail would cost them millions of gallons of fuel. By early 1942, British soldiers fighting across the deserts of North Africa had reached an unusual conclusion. Whenever they found abandoned German fuel cans, they kept them. Not as souvenirs, not as trophies. They used them. British truck drivers quickly noticed something strange. The captured German containers survived journeys that destroyed British ones. They bounced across miles of rocky desert without splitting open. Their lids rarely leaked. Fuel poured smoothly, even when a man was exhausted, dehydrated, and trying to refuel under enemy artillery fire. At first, many officers assumed the stories were exaggerated. Then they started paying attention, and the evidence became impossible to ignore. The North African campaign punished equipment more severely than almost any other battlefield of the Second World War. Temperatures regularly climbed above 110 degrees Fahrenheit. Steel expanded during the day, then contracted sharply after sunset. Every truck vibrated across endless miles of rock, sand, and corrugated desert tracks. Anything poorly designed failed quickly. Engines overheated. Suspension systems broke apart. Wood cracked. Rubber deteriorated. Fuel containers suffered particularly badly. Every vibration weakened welds. Every impact stressed the handles. Every mile increased the chance that precious gasoline would slowly drip away onto the sand. For soldiers at the front, losing fuel wasn't simply inconvenient. It could become fatal. A tank without gasoline became an immobile bunker. A truck stopped delivering ammunition. An ambulance never reached wounded men. Entire offensives slowed because fuel failed to arrive. Military historians often describe logistics as the invisible side of warfare. But for the men actually waiting beside empty fuel tanks, it wasn't invisible at all. It determined whether they lived or died. British engineers eventually disassembled several captured German cans. At first glance, nothing looked particularly revolutionary. The steel thickness seemed ordinary. The size appeared almost identical to Allied containers. Yet every closer inspection revealed another thoughtful improvement. The handles distributed weight perfectly. The pressed X-shaped panels increased rigidity. The welded seams resisted repeated stress. The lid sealed tightly without requiring excessive force. Individually, each improvement seemed small. Together, they transformed the entire product. Word spread rapidly through Allied headquarters. Reports arrived from mechanics, quartermasters, truck drivers, armored units. Everyone seemed to reach the same conclusion. Germany had accidentally, or perhaps intentionally, created the finest portable fuel container in the world. Soon, British troops actively searched battlefields after every engagement. Not only for weapons, but for jerry cans. The nickname came naturally. Jerry was the common British slang term for German soldiers. If the can belonged to Jerry, it became the jerry can. The name survived long after the war itself ended. Back in Britain, engineers received orders that sounded wonderfully simple. Copy it. Exactly. On paper, the assignment looked easy. The Allies possessed enormous industrial capacity. American factories produced tanks by the thousands, aircraft by the tens of thousands. Surely copying one steel fuel can wouldn't present much difficulty. They were about to discover that copying appearance was far easier than copying engineering. When American manufacturers first examined the German design, they understandably focused on its visible features. The rectangular shape, the triple handles, the reinforced sides. Those elements were obvious. Easy to measure. Easy to reproduce. Factories quickly prepared production lines capable of manufacturing millions of similar containers. From a distance, the American version looked almost identical. Most soldiers couldn't tell the difference. Neither could many officers. Unfortunately, the most important improvement wasn't visible from the outside. It was hidden inside the pouring system. German engineers had designed an internal air passage allowing fuel and air to move simultaneously. As gasoline flowed out, Air replaced it smoothly. No vacuum formed inside the container. No violent glug, glug, glug. The stream remained steady from beginning to end. This accomplished two remarkable things. It dramatically reduced spills, and it significantly increased pouring speed. Few people appreciated that difference until they tried both versions side by side. Then the superiority became obvious. The first American copies omitted that internal air-breathing feature, not because engineers lacked intelligence, not because factories couldn't build it, simply because many people underestimated its importance. After all, it was hidden, invisible. Why complicate manufacturing with an internal feature nobody would ever see? The answer arrived almost immediately. When soldiers began using the copied cans, fuel surged unevenly. Air struggled to enter. Gasoline splashed across engines, uniforms, and the ground. Mechanics complained. Truck drivers complained. Tank crews complained. The copied can looked right. It simply didn't work quite as well. There were other differences too. Some early American cans used manufacturing techniques better suited to rapid mass production than long-term durability. Others employed different steel quality depending on factory availability. Certain lids proved harder to seal. Some leaked after repeated use. Individually, these seemed like minor imperfections. Collectively, they created exactly the problem the Germans had spent years eliminating: tiny losses, repeated millions of times. Imagine one fuel can leaking only a few ounces during transport. Hardly worth mentioning. Now imagine 1,000 cans, 10,000, 100,000, across entire armies operating every day. Those tiny losses became rivers of wasted gasoline. The mathematics of logistics are merciless. Small inefficiencies multiplied into enormous consequences. That was precisely why German engineers obsessed over details others considered trivial. American industry responded exactly as it always had, by improving. Engineers collected reports from combat units. Factories modified production methods. Design revisions appeared. The famous camlock lid gradually replaced less efficient alternatives. Manufacturing tolerances improved. Later production models became significantly better than the earliest copies. American industry possessed one enormous advantage. Once it recognized a problem, it usually solved it very quickly. Ironically, the German design itself had not been created by a massive government committee. It emerged because individual engineers repeatedly asked practical questions. How does a tired soldier carry this? How fast can one man refuel a truck? What happens if the can falls from 6 feet? Can it survive months bouncing across terrible roads? Can someone open it while wearing gloves? Can it pour without a funnel? Every answer produced another improvement. None appeared spectacular alone. Together, they created one of the greatest industrial designs of the 20th century. As the war continued, American factories manufactured millions of increasingly refined jerry cans. Eventually, the differences between Allied and German versions became much smaller. But military planners never forgot the lesson. Engineering isn't only about copying what you can see. Sometimes, the feature that changes everything is hidden where almost nobody thinks to look. And that lesson would survive long after the guns fell silent. Because decades after World War II ended, engineers around the world were still building fuel containers based on the same German design. Not because Germany won the war, but because good engineering has a way of outliving the nations that create it. By the spring of 1945, the outcome of the war in Europe was no longer in doubt. The Wehrmacht was retreating on every front. American factories were producing more trucks, tanks, aircraft, and fuel than Germany could ever hope to match. From a purely industrial standpoint, the Allies had won. But inside logistics schools and engineering offices, another conversation had quietly begun. How had Germany, with fewer resources and less fuel, managed to design a better fuel container than the world's greatest manufacturing powers? The answer had nothing to do with luck. It had everything to do with philosophy. After the fighting ended, Allied engineers began carefully documenting thousands of German inventions. Some were obvious: jet aircraft, advanced submarines, rocket technology. Others received far less attention: portable bridges, field kitchens, medical equipment, and, surprisingly, the humble jerry can. Engineers who studied it reached an unusual conclusion. It wasn't simply well built. It was intelligently designed. Every curve, every weld, every handle, every stamped reinforcement existed for a reason. Nothing had been added simply because it looked impressive. One American logistics officer reportedly summarized the lesson perfectly. The Germans didn't build a fuel can. They built a system. At first, the statement confused many people. How could a steel container be a system? Then he explained. A single can affect manufacturing, loading, transportation, storage, refueling, maintenance, recovery, even battlefield salvage. One well-designed object improved every step that followed. That was the true genius behind it. Take the three handles. Many people still assume they were included only to make the can easier to carry. That was only part of the story. Imagine a truck arriving with hundreds of full fuel cans. Soldiers form a human chain. One man lifts. Another receives. Another stacks. Another loads. Because of the triple handle arrangement, each person could naturally pass the can sideways without awkwardly changing grip. Seconds disappeared from every transfer. One can saved perhaps 2 seconds. 500 cans. Suddenly, an hour had vanished. Multiply that across thousands of supply convoys during the war, and those seconds became weeks of operational time. That is what military logistics looks like. Winning through tiny advantages repeated millions of times. The reinforced X-shaped sides offered another lesson. Many people believed they simply strengthened the metal. They did. But they also allowed the steel walls to flex slightly under pressure instead of cracking. Imagine dropping an ordinary metal container onto solid rock. The force concentrates along flat surfaces. Eventually, seams begin separating. The jerry can distribute that force throughout the entire structure. The result wasn't merely a stronger container. It was a longer-lasting one. A can surviving 5 years instead of 1 represented enormous savings for any army. Then came one of the least appreciated features of all: air expansion. Gasoline expands dramatically in extreme heat. North Africa regularly pushed temperatures well above 100 degrees Fahrenheit. Poorly designed containers sometimes bulged. Others leaked. Some even split along their seams. German engineers anticipated this long before the First Desert Campaign began. The jerry can incorporate sufficient internal space and structural flexibility to accommodate thermal expansion far better than many competing designs. Once again, an invisible engineering decision solved a battlefield problem before it happened. Perhaps the greatest compliment came not from historians, but from soldiers. Veterans who had used both Allied and German cans often reached remarkably similar conclusions. Ask them about tanks. They might disagree. Ask them about rifles. The debate could last all night. Ask them about fuel containers. Many simply smiled, then pointed toward the jerry can. Practical experience had settled the argument decades earlier. American industry, however, deserves an important part of this story. Once engineers recognized what they had initially overlooked, they didn't ignore the problem. They improved. Production methods evolved. Later American jerry cans incorporated many of the German innovations that early copies had missed. Manufacturing quality increased. Seals improved. Pouring systems became more efficient. By the end of the war, Allied versions had become far better than their earliest predecessors. That willingness to study, adapt, and improve represented one of America's greatest industrial strengths. Winning wasn't about refusing to learn from the enemy. It was about learning faster. The story didn't end in 1945. Far from it. As armies around the world rebuilt after the war, very few abandoned the jerry can concept. Instead, they copied it. Britain, France, Canada, the United States. Eventually dozens of other countries. Some modified dimensions. Others changed materials. Steel gradually gave way to modern plastics in many civilian applications. Yet the basic architecture remained astonishingly familiar. The triple handles, the rectangular body, the reinforced sides, the secure locking cap. Engineers continued improving the original concept rather than replacing it. That alone says something extraordinary about the quality of the original design. Today, many people load fuel into generators, tractors, boats, or off-road vehicles without giving the container a second thought. Look closely at almost any modern military or heavy-duty fuel can. Its ancestry becomes obvious. The silhouette created in Germany before the Second World War still survives. Not because of nostalgia, not because of tradition, because after nearly a century, engineers still haven't found a fundamentally better solution. Very few industrial products can make that claim. Military historians often remind us that wars are rarely won by one miracle weapon. Victory usually belongs to the side that solves thousands of ordinary problems better than its opponent. Reliable boots, better radios, efficient medical care, stronger bridges, dependable trucks, and sometimes a better fuel can. Those quiet improvements rarely appear in movies. Generals seldom mention them in victory speeches. Yet armies depend on them every single day. Without fuel reaching the front, no famous tank could advance. No fighter aircraft could take off. No bomber could leave its runway. Behind every dramatic battlefield victory stood an invisible army of engineers solving problems most people never noticed. That is what makes the jerry can such a fascinating piece of history. It wasn't revolutionary because it looked different. It was revolutionary because someone cared enough to perfect details everyone else ignored. A smoother pour, a stronger weld, a better handle, an internal air channel hidden where no customer would ever see it. Those tiny decisions saved fuel, saved time, reduced frustration, and ultimately helped armies move farther, faster, and more reliably across some of the harshest battlefields in history. The title of this story says America copied Germany's jerry can, but missed one genius detail. That is true, at first. But the larger lesson is even more important. The Allies didn't win because they believed they were always right. They won because they recognized good ideas, even when those ideas came from the enemy, and then used their unmatched industrial power to improve and mass-produce them. Nearly 80 years later, the jerrycan remains a reminder that history isn't shaped only by famous generals or legendary weapons. Sometimes, the most important invention of an entire campaign is the one sitting quietly in the back of a truck, carrying 20 liters of fuel, waiting for the moment everything else depends on it.